Okay, did you get it? You got both of them? Okay, so the first one, what's one way to solve this? Thank you. And we get take the square root of both. Can't forget that plus or minus. Is that the way you would be inclined to do this problem in general? I see we have a change in plans. We're in terms of movement. Okay, what's the other way? Yes, Ella. You get the same thing. You can't go wrong. And factoring is good, so we can use which property? Zero product property. Or zero product principle. Either way, ZPP. Sorry, I got my schedule. It's okay. I'm glad you made it. Okay. Class is filling in. For this next problem, would it be appropriate to take the square root of both sides? You can if you want. And you get x equals plus or minus 5 root x. Is that okay? Although it's true, it's not really a satisfying end to an equation, is it? If you want to know what x equals and then I have x in the answer, we have a little bit of a problem. And a lot of people did that on the quiz. So I just want to bring that up. Make sure that your answer is making sense. And if it's not, maybe you could say something like, definitely wrong, but I have no more time. Or oops, or something like that. But don't just leave an answer like that and hope that it's okay. I'll go ahead and give you back your quiz now. Not too bad overall. Not too bad overall. It was, I think there was one perfect. I'm in pass you guys, so that's correct. Well, please remember that your test corrections have to be correct. Also, I have a gift for you. Thank you very much, packet. Make sure y'all have up to date with computer. So I have given you the packet today. You know why? Why it's today? I think I told you about the teach ahead. I'm gonna be doing a teach ahead because if I don't do a teach ahead, then you'd be taking the test on Friday, and the other classes would be taking it on Monday, and it just what doesn't seem equitable that they get a weekend and you don't. So I'm introducing anyone who's teaching advanced algebra 2 today is doing a teach ahead to kind of offset that. So next time we will have our review for the test. So that'll be more recent as we approach the test. And that's the story. Make sense? Today. Let's do it. They probably don't want to know. What are the quizzes? What's the test? I was thinking maybe it's more beneficial to write it like this. But our quiz was just on day 4. I put in the hub calendar already. I don't remember what it was about. And then on day 7, we had a student. That test was November 19th. Third test. I do remember. I think this is oddly enough Halloween, and then Veterans Day. I believe that's what we're looking at. Who knows that section 1 is a rather large section. So let's get to it. Oh, it's split over 2 days, but it is pretty large here. Solving a polynomial by factoring. I'm not sure what all that space is, so I'm just going to fill it with ultimately. Use Z, P, P, and or quadratic formula. Complete in this way. And or complete in this way. So example 1. 3x to the 4th equals 27x squared. You might be inclined to divide both sides by 3x squared. Please do not. In fact, right here, I'm going to say never. I think I've mentioned this. Never divide by what? Well, definitely 0, but never divide by an unknown value or a variable expression. So you can divide by 3 if you want. But instead, all I'm going to do is my first step. Oh, we'll put exclamation points there and underline the never. So my first step is going to be to subtract. So we have 3x to the 4th minus 27x squared equals 0. We need that 0. We're setting ourselves up for ZPP. And now we Good. Please finish the problem. When you're finished, check in with your neighbor. Do it all the way up to this whole page. Finish this page, please. I'll count before I go. Again, check in with your neighbor. You have the tools to do all of these. Ready? Let's at least do the first couple. Chloe, can you help me out with number A? Letter A, please. We're good? Thank you. Do we have to factor that x squared minus 9, or could we have used ZPP right there? Yeah, either way. I really like factoring differences of squares. I'm in your in your boat that I would have factored it too by just kind of taking a step back. You don't really have to. Just until you're at a place when you could use it. Thank you, Chloe. K to K, help us out with B, please.
Subtracting 108 x from 7.
Okay. Mm.
0. So 4x equals 0, so x equals 0. And then for the other side of the equation, can you like I added 27 to one side and then did this.
So you start with x cubed minus 27 equals 0. So you get x cubed equals 27 like that. So x equals 3. Are we good? Any questions? Can we sneak any more solutions out of this? Yeah. Sam, you have an idea? Good question. Is it plus or minus 3?
Can be negative if it was negative. It would be negative 27, but if it negative 27 is negative. Right.
Nice. Yeah, and we're thinking what number cubed is equal to 27 and negative 3. Although it works for square roots, you can't just apply it anytime you take any sort of radical. So cube roots, it's just that one. It's just positive 3. So is there another solution? Did no one use, what's that? Pardon? Just 3 and 0? Is that what you're saying? I'm having a hard time hearing. 3 and 0 definitely solutions, but I think we could sneak some more in if you just use soap. Check with your neighbor how you're going to use soap here.
Some said you should say no, can't back in.
How do you use it?
Oh, no, X, this is weird. Maybe this is just like not, because we know the solution that we can get that. And it's where it plus 3x. That's also true. Let's look at that.
Able to do it? Curveball here. So Haley, I'm going to give you the first option to continue right from here if you'd like, or I will pass the torch if you'd prefer it to not. Okay. So we'll just spread the wealth a little bit. Katie, do you have any idea here?
Not really.
Well, we're using soap, and it's appropriate to use soap because this is a difference of cubes. So we'll think about this as x cubed minus 3 cubed equals 0. In my head is what I think, but I wouldn't actually write it like that. So, Katie, do you remember by any chance what the first expression would be? Is it x minus 3? Yeah, it's the same, right? So since we start with a minus, it's x minus 3. Well, we definitely know at the end is going to be plus 9, isn't it? But that plus 3x, is that right? 3x is plus 3x equals 9. Thank you. So we could see that the answer that Haley got before is still there, isn't it? With ZPP, that x is going to be equal to 3. We didn't lose it. It's not like A 4x? Oh there's the left side. Yeah, that's still there too. Thank you. I was just working on the cubic part, but we can't forget about this, but where we came from. But what am I supposed to do with the x squared plus 3x plus 9? Either factor it if we can, or
Huge balance there.
you can never factor this. You could try. Quadratic formula. Yeah, we factored it. And now we're using some ZPP here, right? If we're doing x squared plus 3x plus 9 after we factored, we could still solve, but we're going to have to use some quadratic formula here. Are you singing the song as you do this formula? Yes.
You have a plus or minus, do you still separate the I into the F? Like, do you still separate, would you write it as 3/2, one thing, plus or minus 3√3/2 I, or would you keep it all together and it's a plus or minus?
So if you're saying there's a complex number with imaginary parts, so I want it in complex number form. I want A plus BI separate.
And if there's a plus or minus,
Plus or minus.
Then you can do plus or minus.
oh,
It's fine. You can put them together, consolidate.
okay.
Okay. Katie, do you want to finish or shall I call on someone else?
Do I just slide the answer?
Sure.
Plus or minus 3I.
3i root 3.
So,
Okay. And we could all see the quadratic formula kind of happening here. Nice.
also,
Was it positive 3? Negative 3. Okay, are we done? Yeah, Ella? Split it up. Yeah. Pull a Moses. So x equals -3/2 plus or minus. And then put this in pure complex number form. But you could if you're afraid, you could stick the I where it was with where Katie put it. But I hope you understand what I'm saying. The answer as it was is a complex number divided by 2. I just want the complex number. I want the A plus BI when it is a complex number with an imaginary portion. So how many solutions do we have? And we can't forget that 0. So x equals this, 0 and 3. So when you put your box, if you have a question like this on a test or quiz, don't forget the easy parts too. That x equals 0, by the way, is called a trivial solution. Trivial solution, just kind of like, you can kind of get it just by looking at it, can't you? X equals 0, yeah. Right? Just looking at the problem, you can see that x equals 0. It's a trivial solution, but we need to be able to get that algebraically. Okay, C, I need some help. At least for 200. Yeah. You're doing C? Okay.
minus 4.
Equals 0, I imagine. Okay.
X squared times x plus 1 plus, wait, no, minus 4 x plus 1. And then back to measure thing, and we have x plus 1 times x squared minus 4. And so you get your answers as -1 plus or minus 2.
Any questions? If it's set to factor completely, like solve by factor completely, then I would expect you to break up that difference of squares. But just as solve by factoring, you did that, and then you got the answer. Use EPP is perfect. Yay! I feel like you could already do D. I want to move on. Oh, but what is the answer? Like, I just want to hear the answer. What x equals? Plus or minus 2 and 3 halves, -3 halves? like that. Do we agree? Okay. So if you haven't done it, that's what you should get. Radical equations. I think you could probably already know the answer to A. How many solutions does it have? Just one, and on the count of three, I'd like to just call it what that answer is. 1, 2, 3. 81. So what process, instead of just knowing that the square root of 81 is equal to 9, what process would you have to use algebraically to get that 81? Square both sides. So squaring is the inverse of a radical of square root. It undoes the square root. So x is equal to 81. Yay. Discuss B with your neighbor. Don't call out the answer, but quietly discuss with your neighbor. Okay. So algebraically, if you square both sides, you get x equals 9. But does that work? Is it true that the square root of 9 is equal to -3? Well, it depends what how the problem's given. Remember, this applies to the positive square root. It's called the principal square root. So if we started with x squared equals 9, then yes, x would equal both plus or minus 3. But as it is, algebra has led to a solution that doesn't work. Do you know what that's called when it leads to a solution that doesn't work? Starts with an EX, extraneous. Have we had some answers that were extraneous so far? I think maybe rational. Like if you get that number on the bottom, that this doesn't work. So X does not, there is no solution. So for these radical equations, I'll put a note up here. Always check for, and I underline that always, extraneous solutions. All right. Yes. I think that's like start with extraneous only, but I want to see that you got there and then like cross it out and then put no solution or whatever other solutions are. Be those. Maybe you made it. We're happy. And you got Smashing Pumpkins on your shirt. Amazing. I didn't play Smashing Pumpkins today. It's close. Okay, next. Okay, for example 2, we have another radical equation. The first step, move the 2 in this case. We want to isolate the radical. I don't know why there was so much room for notes in the polynomial portion and none in the radical portion. Seems like this would be appropriate to say here. You need a packet. Packet for me. Oh, you got a new one. Yeah. What we read today will not be on the test, I'm sorry to say. Not this next thing. But ZPP will be. Isolate, I'll put the notes in here. The radical. If possible. Possible. And after you isolate it, next step is to square both sides. Would you square both sides? And do you recognize the danger in squaring both sides, by the way? Yeah, be careful. Just check with your neighbor as you square both sides that it's done in a safe manner. Good. I'm squaring the left and I'm squaring the right. Is this what you're thinking? On the left side, we're left with 2x minus 1. On the right side, how many terms do we have? There needs to be 3 terms. X squared minus 4x plus 4. Did you get that? Okay. Please finish.
One.
I will call someone to help me finish this. Okay, so maybe we're able to finish this one? What's that? Okay, can you help us with it?
Um,
I'm sorry.
from here on, or are we going to be?
Oh, from here on, finishing A.
So you just kind of, get the equation all on one side and then 0 on the other. So x squared, minus, 6x plus 5. And then you can factor that to x minus 1, or x
One.
minus 1 times x minus 5, or something. And then x equals 1 and 5.
Are we good? It doesn't? Yeah, you missed a portion of this where for radical equations, you always have to check for extraneous solutions, which means you take whatever you got and see if they work. So you're saying that one doesn't work? Let's see.
Plus 2, yes, it does.
Yeah, not on this planet.
10 minus 1 is 9, root 9 is 3, 3 plus 2 equals 1.
You see what's going on? Does 2 plus 2 equal 5? What book is that from? 2 plus 2 equals 5. Let me know when you read that book. I'll let you finish B.
What's that book?
There's lots of pages with words, story.
Yeah.
It seems like you should be in Hitchhiker's Guide to the Galaxy. Do they? Did you finish?
It's like, it's, oh, mistakes probably fish. No,
There's so many,
introduce
like,
your
random
ones.
Oh, yeah. I thought you did.
Check in with your neighbor when you're done or stuck. It's nice to have even pairs. But I'm glad you're not alone today. I'm gonna call on someone in about 10 seconds. Make sure that you discuss with your neighbor, especially if you're unsure about anything. Here, Ella, can you talk me through this one, please? Minus 6 x plus 9. Okay. Do we agree? Thank you. Okay, let's move on. Let's get a little bit meatier. Okay. So I told you to isolate the radical. Did I say if possible? Yeah, isolate the radical if possible. And you can see that here, not possible. So what should we do? And we could square it as it is, but what's the problem with squaring it as it is? Would you discuss with your neighbor, what's the problem with this, with just squaring both sides as we have it?
To, realize.
Like, I don't know, it's like one piece, you know, right? Distribute or whatever. It becomes too. I don't know how. That's a flow.
So do you see what the problem is? In our a minus b squared, we could very easily do that, can't we? We know that a minus b quantity squared is equal to a squared minus 2ab plus b squared. So if we're to do this here, the a squared and the b squared would not be a problem. Do you agree that the first and last one would not be a problem? But that middle term is kind of becomes monstrous, doesn't it? So we want to avoid that situation. Although we could do it that way. Like you said, we're going to move one of them to the other side. Which one should we move? Probably the one that makes more sense, one that's being subtracted. Yeah, so we have 3x plus 1 equals 1 plus root x plus 4. And let you finish this problem. Check it with your neighbor. Make sure everything's going well. I do want to call on someone for this. When I say I want Destiny to call on someone. And if you finished it and want to do D, don't let me stop you. Are you ready? Oh, ready or not? I want to see at least how far you came. At least for 400.
Did I square both sides and I got 3x plus 1 equals x plus 4.
Equals. Oh, so you switch them kind of? It seems like you're doing maybe.
Oh, yeah, x plus 4.
Okay, so you're doing this one. Okay, that's fine.
X plus 4 plus 2 root x plus 4 plus 1.
Okay.
And I added it together to get x's power and subtracted both of them. So then on one side I would have 2x minus 4. And on the other side I would have 2x plus 4. Then decided to square it again.
Have you isolated the radical?
I haven't divided by 2.
Divide by 2. And it works out nicely too. There's nothing wrong with squaring both sides, but let's simplify this. So we get x minus 2. Okay.
X squared minus 4x plus 4 equals x plus 4. And then if you subtract the x over 4, you get that, and then you get x. And then the beginning above is x minus 5. So the answers are x equals 0 or 5. And I have not checked yet for straight search.
Okay. 0 is extraneous? You're saying that 1 minus 2 is not equal to 1? What? But let's just keep it because algebra brought us there, right? No, algebra kind of failed us here. But as long as we know that it can fail us in radical equations, we stay ahead of the game. So we cross that out. So our answer is only x equals 5. And that's exactly what I would want to see on the test. There doesn't have to be a final x equals 5. I can see you've already written that. You've already discounted that 0. If you feel like a triumphant x equals 5, that's very nice and you're clean and you want a box like that, that is perfectly fine with me. Questions? Okay. Try D. Make sure to check in with your neighbor when you're done or stuck.
Negative two. Positive two. Yeah, I guess not. Then once you square it, it's four minus three. And then you plug it.
Okay, about 10 seconds before I call on someone. Is that enough time? Oh, ready or not? Look, even if you didn't finish, I want to see at least where you've gone. Haley R, can you help us with D, please? Okay. Cool. Like this? Okay. This X minus 3. X minus 3 like this. Wait, are we okay so far? Is this seems like that there's some disagreement here. Let's see. What's that? So it looks like maybe combining these. Let's see. 4 minus 3 is 1. So that 5 should be a 4. Should 4, is that right? And this 2 is gone. So maybe this. Okay. So this is going to change something. So let's start from here. Let's go back to this. Now I know that this is doing it on the fly because you had gone one direction, but let's talk about this. What's the next step, do you think? We could square it, but I want to simplify just a little bit. So first, before we do that, divide by 4. So we have, I'm going to move the x's to the left. I hope you don't mind if I put it here. Haley, are you comfortable with me doing that? Okay. And now let's take it. Okay. Any questions? Is that the answer? It works? Okay, cool. So 9, so 3 minus 1 is indeed 2. Thank you, Haley. Okay, it's 8:52. We're gonna start again at 8:55. So take some time to zone out, stretch, confirm with your neighbors how much you love this stuff. Oh, it looks like Destiny loves you. I think you called every single time, aren't you? Seems like it. This is fourth time today. Maybe most of it. Maybe two.
Give it check your something now. Oh, figure something.
I'm not doing it.
Is he? No, he has.
Okay, 8:55. We just check to make sure that you could do the date before we continue with this. And make sure it's correct. It says
Says it in the corner.
yeah, 32 to the 4/5. Just need to make sure that's right.
I was trying to do 32. Oh, yeah, that wouldn't have worked. But I was like, oh. Oh, no, 10 minutes.
Okay. How do we think about this? Yes, Jojo. And the fifth root of 32. And to the fourth, 16. So it works. Cool. Are we comfortable with that? Do you see why I want to talk about that with this? So step one, I'm going to rewrite that craziness there as x to the 3/4 equals 2. Now I want to cancel that 3/4. How do I do it? Well, we're going to raise it to the reciprocal so we can multiply those quantities together. Okay, on the left side, we're left with x. On the right side, what is cube root of 16? Is that right? Cube root of 16. Yeah, let's simplify that. I think it simplifies. And make sure you and your neighbor can both simplify that. So the cube root of 16. Sam, what is the cube root of 16? How do we simplify that? 2 times the cube root of 2. Are you comfortable? Just a tip, that's 2 to the 4th root. Let's go back to the 4th root. Let's go back to 3rd grade or 4th grade. When did you do mixed numbers? 5th grade? I don't know. Elementary sometime, not kindergarten, I imagine. So I'm going to rewrite this as 2 to the 1 and 1/3. Do you see this equivalence here? Because 1 and 1/3 is the same thing as saying 2 times to the first plus 1/3, isn't it? which is the same thing as saying 2 times 2 to the 1/3. Just as a point of interest, if it's at all interesting. I would definitely not say, well, in my mind, it's a shortcut. Yeah. Because that fourth one, I'm like, what's a 1 and 1/3? So there's a 1, there's a 1/3. Yeah, Charlotte. Ooh, thank you. Let's take a fresh look. Is that what you're talking about? Just like starting over and seeing a different way to look at this, right? I love that, right? To cancel the square root, we square both sides. So you're saying now to raise it to the, do you like that idea? I think that's a really neat idea that it's perfectly acceptable. So let's do that. Fourth power. So we have x cubed equals, maybe that's even easier, as long as you can get that 16. And of course, the next step is to take the cube root of both sides. So x leaves us right back there. That's pretty. Thanks, Charlotte. Any questions? Okay. Um, let's do A and B. I feel like A is the same problem, isn't it? Did we already do A? Or just like 2 steps before? So you should get the same answer for A. Jojo, did you get B already? Can you tell us what you did? Okay. Would you be comfortable going right to here from here? At your right at your comfort level. I would be okay if you did that. Okay, and then
Power of 2 over 3. So it'd be x equals the cube root of 25.
any questions? Thank you. And general convention is if the problem isn't rational, then the answer should be rational. If the question is radical, then the answer should be radical. So since it starts with this rational exponent, let's just rewrite this as the 5 to 2/3. Mm, but then here that would mean that we have to write it as, well, we did write it as a radical there. Either one is fine. Okay, that's all I got for you. I need to give you some homework though. I haven't assigned it quite yet, but I'll take a couple minutes to do that, and then you'll be able to hop on and get some practice.